Hello, namaste all dear viewers. In this video I am explaining here some practice questions from different topics for the start term of math grade 7. I have posted here timeline where you can find in which time of the which question they are the question answers, so you can easily identify there, so which topic you want to get explained. Let's go. So first I have taken here from the topic of fraction. Three questions I have allocated here. So the first question says here why 12 by 7 is proper fraction. The proper fraction is that one in which denominator is greater than numerator, and that's happening here. Is it 12 by 17? So 12 is the numerator and 17 is denominator. So here 17, which is denominator, is greater. Is it? So if denominator is greater than numerator, such fraction is called proper fraction. So reason is very same. As denominator is greater than numerator, it is proper fraction that you have to say here or write here. And after that, let's go for number B. Define improper fraction. So here works to define improper fraction. So improper fraction is that one where numerator should be greater than its denominator, or numerator and denominator both are equal. Such fraction we call improper fraction. For example, I provide here. Suppose there is 7 divided by 3. Is it? So here 7 is the numerator which is greater than its denominator. So this fraction is improper fraction. Is it? Or you may say 5 by 5. Here numerator and denominator both are equal. Is it? So that kind of fraction we call here improper fraction. So how we have to define here? Fraction in which its numerator is greater than its denominator or equal to its denominator. Such fractions we call improper fractions, you have to say. Now after B, let's go with C. So this is identify any three equivalent fractions of 5 by 7. So here's one proper fraction is given, and for that fraction you have to find here is three equivalent fractions. Infinite equivalent fractions you can find for any given fraction, but we are asked here this three equivalent fraction, and for finding that what you have to do here is by the same number, by the same whole number, or you may say same natural number or integer, by that not 0 other than 0. Alright, natural numbers other than 0 or whole numbers other than 0. By that, if you divide both numerator and denominator, then you can have there is equivalent fraction. So for example I give here, is it? So for 5 by 7, is it? So let's say multiply by 2, so you get there 10 divided by 14. Is it? That's the first equivalent fraction we have here. And the second we can go 5 by 7, let's multiply by 3 by 3. Is it? So it will give another equivalent fraction, 15 divided by 21. Or let's go with other number. Okay, so let's multiply by 5. Is it? So you get there 25 divided by 35. So this one another equivalent fraction. So we are asked here to give three equivalent fractions. So these three equivalent fractions are 10 by 14, 15 by 21, and 25 by 35 for the given fraction 5 by 7. Now after C, let's go with D. Okay, so here is the 2. So here says which fraction is greater? Is it 17 by 6 or is 17 by 7? Okay. So if denominator is same, just by comparing numerator you can say which is greater. Is it? But for here numerator given same but denominators are different, right? So in that case you can convert into some decimal value, or you can make denominator for same, right? And usually the way how we compare two fractions to see which is greater or which is lesser, for that we turn both denominators same when two fractions are given or more than two fractions are given. So for that, first we have to see the LCM of the denominators. So here what we see, LCM of, is it? LCM of 6 and 7, that you find here 42. Then Now what you do here, we make both denominators same by turning it into the LCM. So first 17 by 6, which is the first fraction over here. So let's multiply by 7. Then you get the denominator 42. Is it? So let's multiply by 7. So how much you're going to get here? 7 7 49. 7 1 is 7 and 4 11 we get. So it's 119 by 42. Now go for the second fraction, 17 by 7. There you see denominator 7. So to make its denominator turning into 42, you should multiply by 6. Is it? So 7 6 is 42 you get, right? And after that, so 17 into 6, 7 6 42, 6 1 6 6 4 10. So we get here first fraction as 119 divided by 42, and second fraction we have got here 102 divided by 42. So here now denominator is same, so we can compare numerator to see which is greater. Is it? So here obviously 119 is greater than 102. Is it? Let's write that 119 by 42. This fraction is greater than 102 by 42. So it means what? 119 by 42, it's 17 by 6. Is it? So you say here, therefore 17 by 6 is greater than 17 divided by 7. So you can take it in reverse form. Is it? So if you have to solve the process, you can definitely do like this way. Is it? But if you just need to give the answer without doing the process, is it? So let's take it reverse way. Is it? So reverse way says that, is it, when numerator is same over here, is it, so when you compare denominator, if denominator is lesser, that fraction will be greater one. So without seeing this, what you can say, in this 17 by 6 and 17 by 7, 17 by 6 fraction has consisted with the denominator lesser, so that is why it should be greater. Is it? So you should say here 17 by 6 is greater than 17 by 7 without doing this calculation, just by seeing what is denominator. Is it? So when we see denominator the 6 and 7, for numerator being same only in that case. Alright, so numerator is lesser over there in 17 by 6, so that fraction is greater than 17 by 7, you can say. Okay, I'm done with this number 1. Now I go with number 2. Okay, I scroll it up. Okay, here I've kept the few questions from the topic of laws of indices. Here goes with first question. It says what if two terms are getting divided with same base? So what should we do with its power, right? Okay, so the thing is what here says two terms with the same base, they are getting divided, x power m by x power n. Say what's happening here. So for this we can say what here denominators. Sorry, here powers. So like how to deal with powers, we have to look at here. So as these are divided, powers will get subtracted, and when we subtract, two way we can do. Right, so numerator power of the denominator, is it, let's get subtracted with the power of numerator. So this one we can do, or we can do in another way with this x power by x power n equal to, so we can bring power of the numerator down to get subtracted, right? So x power n is there down, is it, and power m from the numerator we bring it down to get subtracted. And if we do this way, we have to keep here numerator 1. So either of the ways we can do when two terms with same base are getting divided with different powers or same power. Okay, after A, now let's go with number B. Okay, so I do this side. So this is what we are given here to prove one expression equal to 1. So the question is, prove that x power a divided by x power b whole power a plus b. Is it? First term is this, and second x power b divided by x power c whole power b plus c, and last one is x power c by x power a whole power c plus a. So this equal to 1 we have to prove here. So let's start with the left hand side. So this side is left side, right? So from this side we start, and this we would define the rule, right? When two terms are getting divided, their powers will get subtracted. So let's use that, right? So here x power a by x power b. For that, is it? I'm not copying the left hand side. This I'm doing directly. So as these are getting divided, their powers will get subtracted, and whole power a plus b is there. So we do for the second term there. So x power b minus c will take place, and b plus c is there. Same. So similarly we do for last one term, x power c minus a, and whole power c plus a is there. And now here comes the rule, right, for the power of the power. So this side I'll do. Suppose there is x power m and whole power n. Is it? So these two powers will get multiplied. So this rule we have to apply here. So a minus b into a plus b will take place, and same like there will take place another b minus c into b plus c, and the last one we take there c minus a into c plus a. Is it? So it is formed factorization of a square minus b square, which is a minus b into a plus b. Is it? So we can revertly write a square minus b square in place of product of a plus b and a minus b. So we keep here a square minus b square for the product of a plus b and a minus b. Same we do for this b plus c and b minus c, which will produce b square minus c square, and c square minus a square for the last one, right? And what is happening here? These all three terms are getting multiplied, so the powers will get added. So get their powers added. A square minus b square plus b square minus c square plus c square minus a square. And thing is what over here, these all terms which are in power, they are here with positive and negative with same term or same values, right, which we can get subtracted to get 0. So here a square plus a square and minus a square we get cancelled, plus b square and minus b square we get cancelled, and so like c square plus c square and minus c square we get cancelled. So it results here power 0 with the base x. And the thing is what, for any base, if its power is 0, its value is 1. So this way we get RHS proved. So it's for number B. Now we go with number C. And first number C, I make this one erase. Okay, so let's go with number C. What says this? Simplify 8 by 27 whole power minus 2 by 3. Is it? We are given here 8 by 27 whole power minus 2 divided by 3. And very easy way or shortest way to deal with this kind of the problem is remove the negative power turning into positive by reciprocating the base. So here base for the power is 8 by 27. So this we get reciprocated, and negative power we turn into the positive power. So we get the base 8 by 27 reciprocated, and we write 27 by 8, and that power negative 2 by 3 we turn it into the positive power 2 by 3. And one caution you have to take there, we don't need to reciprocate the power. Some of students tend to reciprocate power also. 2 by 3, that 2 by 3 which power we have, alright, they'll reciprocate and they may tend to write 3 by 2, and that will be wrong, alright, not like that. This is what we have to do, we have to reciprocate the base, and power negative which is there, it will turn into the positive power. And after that, this 27 by 8, these two whole numbers are the cube numbers of some values, so let's turn into the cube numbers. So 27 we can write cube of 3, 8 you can write cube of 2, and whole power 2 by 3 is there, is it? And that equal to, now sorry, this power of the power, is it? So the rule is what, just we have said here in above, when there is power of the power, those powers should get multiplied. So we take here 3 power 3 into 2 divided by 3. So we do same for 2 power 3 into 2 divided by 3. And once we do that, So these powers 3 and 3 can cancel, and this 3 and 3 also cancel. So 3 square remains in numerator, and denominator there remains 2 square. So it's 9 divided by 4. 3 square is 9, 2 square is 4. So number C is complete, and I go with number D. Okay, I erase something over here. Okay, this I erase, right? So think what is said here in number D, right? Write this paragraph some 5 into 5 into 5 into 5 in exponential form. So same value is multiplied here for 4 times, 1 2 3 and 4. So it will be here what, 5 power 4, right? So paragraph these 4 times, that we have to write as 5 power 4 in exponential form. So I may declare with number 2, and now I go with number 3. Okay, so in number 3 some questions we do have, and I'm taking it from the topic ratio. Okay, so let's see what we do have here. I move this side to here. Okay, so first question, what do we have to see? Robin plays for 3 hours and he studies for 9 hours. So what is the ratio of time of his playing and learning time? So ratio of these two things, for what he plays and for what time he studies, the ratio we have to take, or we have to find. So for this number we say here ratio of playing time, and starting hours. So ratio of these two things we are finding. So playing time is there given 3 hours, and learning time is given there 9 hours. So this can be cancelled. 3 ones are 3, 3 2s are 9. So this we do have here 1 by 3. So it is what, 1 is 2, 3 is done. Is it? So ratio of playing time and starting hours is 1:3. Okay, number is done. Now let's go for number B. I'll make this clear first. Okay. So in number B said here, arrange in ascending order for a ratio of 1:2, 3:4, and 4:5. So of these three ratios, alright. First ratio we have 1/2. Second ratio we do have here 3/4, and third ratio we have 4/5. Let's see the denominators. What I have to do here is, these all three denominators of these three fractions we have to turn into the same value, and for that we will be taking help of LCM of these values. So LCM is what over here, 2 4 5. Is it 2 1s are 2, 2 2s are 4, 5 1 get divided, same we copy. So LCM is here, product of these three values here. So 4 5s are 20. So what we have to do here is, for all these three denominator fractions, denominators we need to turn into the value of LCM, which is 20. Is it? So let's go with that. So first fraction or first ratio we have 1/2. To turn its denominator 2 into 20, we have to multiply by 10. So we get that 10 divided by 20. So first ratio we get here 10/20. Ratio I have converted into fraction. So first fraction or first ratio we have here 10/20. Now let's go for the second fraction to do the same. So in 3/4. So to turn its denominator 4 into 20, we have to multiply by 5. So 3 5 15, 4 5s are 20, right? And the last fraction is there 4/5, right? And for its denominator 5, to turn it into 20, we have to multiply by 4. Is it? So 16 divided by 20. Is it? So this way we see here similarly 10 by 20, 15 by 20, and 16 by 20, and these are in ascending order already, right? So first you show with the comparative fraction. 10 by 20 compared to this 15 by 20 is greater, and compared to 15 by 20, 16 by 20 is greater. And actually these are 10 by 20 is 1:2, and 15 by 20 is 3 by 4, and 16 by 20 is 4 by 5. So therefore compared to 1:2, 3:4 is greater, and compared to 3:4, 4:5 is the greater ratio. So this way we got this number B done. And I go with number C. So let's see what it says here. Brother John has 250 rupees with him, and sister Lisa has 300 with her. And what happened next is mother gave rupees 30 to John and rupees 20 to Lisa. So now what is the ratio of money they do have now? Is it after making change? Is it so? How much money they do have? We are asked to find the ratio. Is it so? Let's go directly. Is it after mother gave them some money? All right. So John has. Sorry, I mistakenly opened him. Another. Okay, John. Is it so? John has rupees 250 already. He has. Is it and plus? Is it he got added 30 rupees, so rupees 280, is it at present, is it? And Lisa has rupees, initially she was having 300 rupees and mother gave her 20 rupees, is it? So now she has rupees 320, is it? So these are the money which they have after their mother gave them some sort of another money. All right. And now ratio of that money after their mother gave to them, we have to find, is it? So we may say their new ratio of money they have. New ratio of money they have. Right. So it's 280 divided by 320. So first we cancel by 10. 28 by 32 we get, and again we multiply or we divide by 4. 4 7s are 28, 4 8s are 32. So 7 by 8. Now they can be divided, is it? So this the ratio is 7:8. Okay, so it's of number C I let you learn, is it? Now I go with number D. Right. So what says here in number D? Let's see. Let's make this series first. Okay, so for this number D, ratio of weight of Raman and Rohan is given 7:4. Their ratio of their weights is given, and some of their weights is 121 kg. It is said, is it? And the condition is if obesity may cause diabetes, so find the weight of person who is likely to have diabetes among these within these two persons, Raman and Rohan. So we have to first identify what weight they do have, is it? So we suppose their weight in terms of x. So let Raman's weight let Raman's weight equal to here, as 7 part is this, so 7x we say, and then next is one Rohan, is it? Rohan's weight, this we suppose as 4x, is it? And after supposing that, the sum of their weights is given, is it? So sum of their weights equal to, that's given there 121 kg, is it? So it's sum of 7x and 4x equal to 121 kg. So 11x equal to 121 kg we get. So x equal become here 121 divided by 11. So that will be here 11 kg, is it? 121 is square of 11. So if we divide 121 by 11, so result will be again 11. So value of x is found. And once after finding the value of x, now we can find uh, what are the weights of Raman and Rohan. So you say here, then Raman's weight, Raman's weight equal to 7x. So it's 7 into 11 kg. So that will become a 77 kg. And then Rohan's weight. So Rohan's weight is here 4x, so 4 into 11 kg. So his weight is 44 kg. Alright, and now go with the question. What we have to conclude is it? They said obesity may cause diabetes. Obesity, getting more fat in our body or getting more weight, is it? So it may cause diabetes. So there is saying in our daily life, right? So it is said like that. So this is what, find a weight of person who is likely to have diabetes, right? So whose weight is more comparing to these two persons. We could say here that person's weight is, or that person is likely to have diabetes. So here Raman is having 77 kg weight, so he is likely to have here diabetes, we can conclude. So you can conclude by yourself, isn't it? As Raman's weight is more than Rohan's weight, or as Raman's weight is 77 kg, which is greater than Rohan's weight, he is likely, or Raman is likely to have diabetes. So number D is done. Now last one number is there, E number. Let's see with this. Uh, uh, this side how it is. Okay, so what says, you see in this number, we are given here 2 times x, 3 times y, and 5 times z are equal, is it? And through that we are asked to find a ratio of x is to y is to z, right? So what we do here is, right, so first we find x by y and y by z. Let's make it here first. So here we have 2x equal to 3y, first two, is it? So it gives you 2x by y equal to 3, is it? That will give you x by y equal to 3 divided by 2. Very first thing is this, right? And second one, let's go with 3y and 5z equal. 3y equal to 5z we have. So 3y by z equal to 5, we could say. And you can bring the 3 down. So y by z will become here 5 by 3. And now thing is what? Right, we have to find a ratio of all three variables x, y, and z. Is it? So to make for finding that, right, so we have to make a common term with same value, right? So here common term is y, is it? The common variable or common term is y, but they are having different values, 2 and 5, is it? Their values we do have here 2 and 5. So what thing we do here is we make them same, value of y, which is same variable, we make their value also same, is it? So to make their value same, which are here 2 and 5, so we multiply both ratio by flipping the values of y. So where we see value of y as 2, that ratio we get multiplied by 5, and where we see the value of y as 5, that ratio we get multiplied by 2. If we do that sort of thing, then we get a new ratio of those x raised to y and y raised to z, having value of y both 10, is it? And then we can find x is to y is to z. Okay, let's see how I do. So x by y is there 3 by 2. So to turn value of y 10, right? So I multiply by 5. So this way we get here 15 divided by 10. And next one is there y by z, is it? Where y we do have 5, is it? So here we multiply by 2. That way we get value of y also 10, is it? And the thing is what over here, see, now value of y turn same, is it? Value of y here 10, and in second ratio value of y turn also same 10, is it? So we can now find what x is to y is to z, and before that let's write here x is to y equal to 15 is to 10 from the first one, and y is to z equal to 10 is to 6 from the second one, is it? And once we do that, now y, value of y has been same here 10, is it? So we can write here, therefore x is to y is to z equal to 15 is to 10 is to 6. So this way we got here x is to y is to z. Okay, in this video, in this first part of the video, up to this 3 number I've done with 3 different topics to let you revise shortly, and in subsequential video, in next video, I'll be making from the video for the next topics. Okay, stick on over there. Be sure that you'll be watching that video also. Thank you for watching.